All right. Hey guys, this is Mrs. Lyons, and I am going to work through a couple more of these limiting reactant problems for you so that if you go to do your homework and you get stuck, you can take a look at these and see if what you're doing is right or if you need to make some changes. Okay, so we're going to do two problems. This first one says, how many grams of carbon dioxide will be produced if 68.1 grams of solid calcium carbonate is mixed with 51.6 grams of HCl. Okay, so remember we're going to do two gram to gram stoichiometry problems. Okay, we're going to do one starting with calcium carbonate and going to carbon dioxide, and the other starting with HCl and going to carbon dioxide. Okay, so this is the same three steps we've been doing over and over. So 68.1 grams of calcium carbonate, that's CaCO3. Okay, then we need to convert. Okay, remember the first thing we need to do is we need to convert from grams of calcium carbonate to moles of calcium carbonate. And remember that 1 mole of calcium carbonate is equal to the molar mass in grams. So we have to, if we look at our periodic table, we have 1 calcium, which is 40.08. We have 1 carbon, which is 12.01. And we have 3 oxygen. Oxygen 16, 3 times 16 is 48. So that's a molar mass of 100.09 grams. Okay. Now, I'm going to show you how to do this all in one step. Okay. So instead of solving right now, we're just going to go right on to step number 2. Okay. And we can do this because we can cancel our units, and instead of calculating one number and then calculating another and then calculating another, our units will cancel. Okay, so it'll still work out in the end the same. So if you look, we're canceling out grams of calcium carbonate. All right, from moles of calcium carbonate, what we need to do is we need to convert to moles of what we're looking for, so moles of carbon dioxide. Okay, so moles of calcium carbonate goes on the bottom, and moles of what we're looking for, so moles of carbon dioxide, go on top. Now, remember when we have moles over moles, we're looking at our mole ratio, which comes from our balanced chemical equation. All right, so this is balanced. We have 2 HCl and then 1 for all of our other coefficients. So carbon dioxide right here is 1 mole, and calcium carbonate is 1 mole. All right. Now, that allows us to cancel out moles of calcium carbonate. All right. And then the final step that we need to do is to convert from moles of carbon dioxide to grams of carbon dioxide. Okay, so that means we have 1 mole of carbon dioxide on the bottom. And on the top, we want the grams of carbon dioxide. Okay, so the molar mass of carbon dioxide, the molar mass of carbon dioxide, we have 1 carbon, which is 12.01, and then we have 2 oxygen. Each oxygen is 16, so that's 32. So the molar mass of carbon dioxide is 44.01 grams. Okay, and that our moles of carbon dioxide cancel out, and we end up with our final answer is going to be grams of carbon dioxide. So let's do this math. 68.1 divided by 100.09. I don't need to do anything here because these ones just cancel out, times 44.01 gives me an answer of 29.94 grams of CO2. All right, so let's look at this next calculation. Okay, now instead of starting with calcium carbonate, we've got to start with HCl. Okay, so we start with 51.6 grams of HCl. Okay. So again, first step is to go from grams of HCl to moles of HCl. Okay. And for grams of HCl, we've got to add 1 hydrogen, which is 1.01, and 1 chlorine, which is 35.45. That gives me a molar mass of 36.46. That's the molar mass of HCl. 36.46. All right. So now our grams of HCl cancel out. We need to convert from moles of HCl to moles of carbon dioxide, what we're looking for. So that might not be 1. Moles of HCl, and this is where we have moles of HCl and moles of carbon dioxide. Okay. Moles of HCl is going to be 2, because when we have moles and moles of one thing over moles of another thing, that's the mole ratio. All right. So moles of carbon dioxide is 1. All right. So that cancels moles of HCl. So then the third step is to convert from moles of carbon dioxide to grams of carbon dioxide. Okay. So 1 mole of carbon dioxide is equal to, and we calculated it up here, 44.01 grams of carbon dioxide. Now notice something, okay? When you look at this, when you do these stoichiometry problems, once you start looking at your unknown, your calculations are going to be identical, okay? So we've got 1 mole of CO2, and then we've got our mole conversion to grams of CO2, okay? So to know you're on the right track, this last step should be identical, okay? Because we're always going to be looking for the same thing. All right, so let's see, 51.6 divided by 36.46 divided by 2 times 44.01 is 31.14. Okay, now what this is saying, okay, and this is the important thing to understand what we're actually talking about, okay? What we're saying is we are going to react calcium carbonate and hydrochloric acid, okay? And each of these calculations, so this is saying if I start with 68.1 grams of calcium carbonate and have unlimited HCl, okay, I can make 29.94 grams of carbon dioxide. This is saying if I start with 51.6 grams of HCl and I have plenty of calcium carbonate that there's plenty to react, I can make 31.14 grams of carbon dioxide. Okay, so this is kind of like that idea we talked about in class of ham sandwiches. Okay, what do you run out of first? All right, so in these calculations, what this is telling us is that once we make 29.94 grams of carbon dioxide, we will run out of calcium carbonate and we won't be able to make any more product. Okay, so when you look at this, you take the smaller number and you draw an arrow back to, okay, this substance, this reactant, okay, calcium carbonate, is our limiting reactant, which means the other reactant, HCl, is our excess reactant. Now, the one thing I didn't ask here is the theoretical yield. And the theoretical yield is going to be the smaller amount of product. So our theoretical yield is 29.94 grams of carbon dioxide. Okay. All right. Let's do one more. All right. So our last example here, we have 2 moles of sodium plus 2 moles of water produces 2 moles of sodium hydroxide and 1 mole of hydrogen. Okay. So the question is, what number of grams of hydrogen, H2, will be produced if 10 grams of sodium is added to 8.8 grams of water? Okay, now it's important to look at this equation because we have 2 products. We want to make sure we're calculating the right product, okay? In this case, it's H2, okay? So I'm looking for that. I'm going to ignore sodium hydroxide, okay? And you just want to make sure you read your problem so you know what you're looking for. So let's start with 10 grams of sodium. So if I have 10 grams of sodium, okay, first step, we've got grams, we've got to convert to moles. Okay, so 1 mole of sodium is equal to, on the periodic table, if you look, periodic table says that there are 22.99 grams of sodium in 1 mole. All right. Step 2, we have to go from moles of sodium to moles of hydrogen. All right. And that's where we use our mole ratio. So moles of sodium to moles of hydrogen. Okay. So 2 moles of sodium produces 1 mole of hydrogen. All right. And finally, we need to convert from moles of hydrogen to grams of hydrogen. All right. So 1 mole of hydrogen has a molar mass of 2.02 grams. Okay. Because 1 hydrogen, if you look at your periodic table, is 1.01. We have 2. Okay. So let's calculate this. All right. So 10 grams divided by 22.99 divided by 2 times 2.02 is 0.43. So we're going to say 0.44 grams, 0.44 grams of hydrogen. Okay. Now we need to compare that to starting with 8.8 grams of water. Okay. So first step is always to convert from grams to moles. So 1 mole of water has a mass of, we got to look at our periodic table. Oxygen, we know, has a mass of 16. Hydrogen has a mass of 1.01. We have 2 of them, so 2.02. So my molar mass of water is 18.02 grams. Okay, now the next step, once we've got moles of water, we need to convert to moles of hydrogen. Okay, so we have moles of H2O on the bottom and moles of hydrogen on the top. Okay, so if I look at my balanced chemical equation, 2 moles of H2O produces 1 mole of hydrogen. And then finally, we have to go from moles of hydrogen to grams of hydrogen. So 1 mole of H2 has a molar mass, we already calculated it up here, of 2.02 grams. All right, so let's do this calculation. We've got 8.8 divided by 18.02 divided by 2 times 2.02 is 0.49. So 0.49 grams of H2 is produced. Okay, so these are our 2 possible answers, 0.44 grams and 0.49 grams. Okay, so this being the smaller amount, we have to draw our arrow back. What did we start with? We started with sodium. Okay, so our limiting reactant is sodium. Our excess reactant is water. Okay, and this number, okay, our theoretical yield. is 0.44 grams of hydrogen. Okay, so there you have it. Hopefully, the more you do this, I know I'm a broken record, but practice makes perfect. And the more that you practice this, the easier it will be and the quicker that you will be. All right, I hope that helped. I will see you in class. Take care of yourself.